Good afternoon. For our presentation, we will be discussing the industrial internet. The members of this group are myself, Macy Rowe, Jonathan Madrid, Carrie Roulette, and Abby Brazil. To give a brief overview of our presentation, we will begin by explaining what the industrial internet is, the industries it impacts, and is applied to. We will then take you through two different scenarios that outline the supply chain without the industrial internet innovation, and one that shows the benefits of implementing the innovations through the industrial internet. Through these scenarios, you will get an idea of different supply chain implications. Then we will close with how the industrial internet will impact our chosen industry in the future. So what exactly is the industrial internet? The industrial internet by itself is a revolutionary digital innovation that is changing significantly the way machines and humans communicate, how data is stored, analyzed, and exchanged, and in the big picture is changing how the world functions. The industrial internet is about making machines that are brilliant and, by using a system of sensors, are capable of storing data that is later transformed into valuable productivity and efficiency improvements. With the industrial internet, there are several industries that are being impacted, including healthcare, agriculture, manufacturing, logistics, the oil and gas industries, and others. But for the purpose of our presentation, we will be focusing on the logistics industry. Why railroads? More specifically than logistics, we are going to dig deeper into the railroad industry. The railroad industry has a large impact on the logistics industry as a whole. If the industrial internet can be properly implemented, it would increase efficiency for the whole supply chain industry because of its already significant impact. This innovation has positively influenced the railroad industry by easing the economic situation surrounding the railroads and the competition against the trucking industry.
In order for you to have a better idea of what the implications of a real-time data and process automation in the railroad industry are, we are going to show you a real-life scenario of an inefficient intermodal movement by BNSF Railway. The players in this example are BNSF Railway as the focal firm, J.B. Hunt as the 3PL provider, Maersk as the ocean carrier, the Port of LA, a drayage carrier company, and Walmart as the end customer. In this scenario, BNSF has no industrial internet capabilities other than the current fuel-efficient locomotives that GE has released to the market. This example is about Walmart goods being transported from China to Kansas City by using a J.B. Hunt container and J.B. Hunt using BNSF services. Everything starts when the container is ready and loaded onto the ship at the port of Shanghai. The container leaves the port in China and starts sailing through the Pacific Ocean. During the ocean trip, there are some mechanical issues that slow down the vessel. As a consequence, the ship docks at the port of LA 15 hours over the expected arrival time. Then, when the container is discharged from the vessel, it is not placed on a chassis immediately as it was supposed to. It is rather placed on a stack of containers by the crane operator at the port. When the drayage carrier comes to pick up the container to take it to the BNSF intermodal ramp in LA, he finds out that the container is not wheeled, so he has to wait for a port crane operator to take the container out of the stack and put it on a chassis. After the container is finally ready for pickup at the port, the drayage driver takes the container to the rail terminal. The train is expected to depart at 2 p.m. that day. However, because of an unexpected mechanical failure in one of the locomotives, the train is delayed for 1 hour until the problem is solved. The train finally leaves LA on its way to Kansas City. The account manager for Walmart at J.B. Hunt cannot know the exact location of the container unless the train passes through certain cities where it is manually spotted by a train dispatcher. So the real-time tracking system of today is not quite real-time. The train arrives at the Kansas City Intermodal Terminal. The container is unloaded and taken to the Walmart distribution center. Finally, Walmart receives the container at a later date than the promised one, even though the container was classified as priority. This is a very typical scenario in today's industry. Currently, most of these problems are inevitable.
From the scenario, we can see several supply chain problems. By implementing the innovation of the industrial internet to provide solutions to these problems, we can see several supply chain implications, including cost reductions, increased visibility, time savings, and overall improvement in the company's business models. One of the problems seen in the scenario is the mechanical issues in ocean transport. This problem can cause high maintenance costs. The industrial internet can improve this by implementing engine sensors. Sensors installed throughout the ship collect data about the health of every component and sends alerts to the captain or engineers aboard the ship to take preventative action. This will lower costs over time as maintenance work can be completed before a potential problem has become too costly. The prevention of maintenance earlier in the supply chain will provide massive time savings as well. Another implication relates to visibility of containers moving through the supply chain. The drayage driver in the scenario was unable to pick up on time because he couldn't locate the container. Implementing a real-time container information transfer system would allow members of the supply chain to get frequent updates on locations and provide them with greater visibility during the entire shipment process.
Businesses often have trouble tracking their loads during the transportation process. Many of these companies build business models that reflect their lack of data. The industrial internet will help companies track their products during shipment by increasing the connectivity across the network. This will improve communication with customers and allow companies to restructure their business models to take advantage of new and complete data. Data will be easily accessible and provide accurate location information. All stakeholders and their business models will be benefited. As innovation continues in the industrial internet, there will be improvements in many areas of the railroad, including new markets, new products, delivery, tracking, and increased economies of scope. This short video will help you visualize the future benefits with innovation of the industrial internet in today's supply chain management business.
The next industrial revolution is here. It's big iron plus big data, hardware and software, minds and machines. The most profound convergence of industry and technology that will build opportunities and productivity, intelligence and connectivity that could add about $15 trillion to global GDP by 2030. By creating lots of little efficiencies that create fuel savings, better scheduling, reductions in delays and cancellations, more efficient maintenance. It all adds up. Just a 1% improvement in aircraft engine maintenance efficiency can reduce related costs by $250 million annually. Just a 1% reduction in operating ratio could result in a $600 million a year savings for North American railroads. Just a 1% fuel savings in power generation could add more than $4 billion annually to the global economy. It's now a faster, safer, cleaner, more productive world. And it will be greater than what we've ever done before. The industrial internet is here.